Hello, my name's Evan and I am a student at the University of Newcastle. Today I'm going to be talking about organic photovoltaics. What is a photovoltaic, you ask? Well, it's just a complicated name for a solar cell. The difference between organic solar cells and traditional silicon one is that silicon solar cells require a lot of energy and cost to produce, whereas organic ones can be printed, so they can be printed on a huge reel-to-reel printer at a fraction of the cost. Generally, for a square meter of silicon solar cell, it costs about $80 to $120, whereas we can produce a square meter of organic solar cell for only about $8. It's much cheaper. So, how do they work? Well, here behind me is a diagram of the solar cell. It starts off with a positively charged cathode, and the electrode on the other side is called the anode. Now, the way to remember the difference between these two is just remember the cats are positive. Now, on top of the cathode is a buffer layer that is printed on. Now, this enables the electron to move from the active layer up here into the cathode, which then comes over here to generate our light. The active layer is where all the magic happens, where everything, where all the really cool stuff happens. What happens is the photon, which is all these red things, hits the active layer, so it goes through these first two layers, hits the active layer, and excites an electron in there. This is really cool because as the energy is transferred, the electron is promoted, and what this means is that it generates a positively charged hole. And what this means is that if we can get that excited electron out, we can create a charge with it. So what happens is it moves from the active layer into the buffer layer, and then from there into here, and then off it goes to our light. Now, the positively charged hole, which is just sort of the space where the electron was, moves to the anode and then goes down to charge the light. So it's quite simple, but there are quite a lot of issues. The active layer is the most interesting because the combination of the two polymers that are there determines on how the hole and the electron get removed from each other, and the more efficiently we can do that, the more charge we can create. So this is made by printing layers on top of each other. So this means that we can use a large reel-to-reel printer and just print out hundreds of meters a day. This is really, really good. At the moment, our efficiencies for the large scale are really, really small. But once we get to a higher efficiency, we will be able to generate so much power. This is really, really exciting because there are many, many countries all over the world that have very low energy security, and their infrastructure is not there to produce power for the majority of their population. What we can do is we can provide small scale, flexible, portable solar cells that they can use all over the place. Imagine being able to go camping and charge your mobile phone from a cell that you just roll up out of your bedroll. It's amazing. Thank you very much for listening to me. I hope that you've learned a couple of things, that cats are positive and that organic solar cells are amazing.